In the late 1970s, a French-Canadian archaeologist named Jacques Cinq-Mars crawled into 3 small caves on a frozen ridge in the northern Yukon and found something that should have rewritten every textbook in the Western Hemisphere. Cut-marked bones of extinct horses and woolly mammoths sitting in sediment dated to roughly 24,000 years ago, a full 10,000 years before any human was supposed to exist anywhere in the Americas. He presented his findings at conferences. They laughed at him. At one presentation, in his own words, they found him cute. He stopped attending conferences. He stopped defending the site publicly. He spent decades watching the field ignore evidence it simply was not ready to accept. Then, in 2017, a researcher who had never met him walked into a museum storage room, opened his old bone collection, and proved he had been right the entire time. The Bluefish Caves sit on a limestone ridge overlooking the upper Bluefish River, deep in the Keel Range of the northern Yukon Territory. You cannot drive there. You cannot hike there on any maintained trail. The only way to reach this ridge is by bush plane or helicopter, landing on terrain so remote that the nearest permanent settlement, the small village of Old Crow, is itself one of the most isolated communities in all of Canada. 3 small cavities, carved into the limestone by millennia of freeze-thaw cycles, sit along that ridge. None of them are large enough to call a proper cave by most people's standards. They are shallow hollows, barely deep enough to shelter from the wind, their floors filled with compacted loess, the fine wind-blown silt that accumulated inside them grain by grain across tens of thousands of years of Arctic exposure. Here is the detail that makes this specific location so significant, before a single bone is ever mentioned. This ridge sits inside what geologists call Eastern Beringia. During the last ice age, when so much of the planet's water was locked inside glaciers and ice sheets that global sea levels dropped dramatically, an enormous stretch of land emerged between Siberia and Alaska, connecting the 2 continents directly. That land bridge, Beringia, was not a narrow footpath across the water. It was a genuine subcontinent, over 1,000 miles wide in places, covered in steppe grassland, populated by mammoths, horses, bison, and caribou. And the Yukon side of that land bridge is exactly where these 3 small caves are sitting. Think about what that geography actually means for anyone trying to trace the very first human footsteps onto this continent. If the ancestors of all Native American peoples originally crossed from Asia into the Americas, as both genetic evidence and the archaeological record strongly suggest, then Beringia is the doorway they came through. And any physical evidence of those earliest arrivals, any tools, any butchered bone, any trace of a campfire lit by human hands during that crossing, would most likely be found in exactly this kind of terrain. Cold, dry, unglaciated ground, sitting directly inside the land bridge corridor itself. In the late 1970s, one man decided to go looking for exactly that kind of evidence. Jacques Cinq-Mars was a French-Canadian archaeologist working as a curator at what is now the Canadian Museum of History in Gatineau, Quebec. By all accounts, he was not a man built for office work. Tall, grizzled, and weather-hardened, Cinq-Mars lived for summer fieldwork, spending months at a time combing the Yukon's most remote riverbanks and rock shelters for any trace of Ice Age human activity. He had already spent years studying the Old Crow region before he turned his attention specifically to the Bluefish Caves. And once he did, he committed to the project completely. Between 1977 and 1987, a full decade of sustained fieldwork, Cinq-Mars and his team excavated all 3 caves systematically, working through the frozen loess deposits layer by careful layer, cataloging everything they found with the same methodical rigor any serious archaeological excavation demands. The conditions were brutal. Summer fieldwork in the northern Yukon means insects, extreme remoteness, supply lines stretched to their absolute limit, and weather that can turn dangerous with very little warning. The caves themselves offered no shelter worth mentioning. Every piece of equipment, every sample container, every tool needed for careful excavation work had to be flown in and flown out on small aircraft barely suited for the terrain. And yet Cinq-Mars kept coming back, season after season, for 10 straight years. Whatever he was finding inside those frozen loess deposits was significant enough, compelling enough, to justify a full decade of genuinely difficult, physically demanding work in one of the most remote archaeological settings anywhere in North America. What he eventually pulled out of that sediment would haunt his career for the next 30 years. Inside the loess deposits filling those 3 small caves, Cinq-Mars and his team recovered the bones of animals that had been extinct on this continent for thousands of years: woolly mammoths, Ice Age horses, steppe bison, caribou. The remains of an entire vanished ecosystem, preserved in frozen sediment that had been accumulating grain by grain inside these shallow limestone hollows for tens of thousands of years. Finding Ice Age fauna in Beringian cave deposits was not, on its own, particularly unusual. The Yukon had already produced significant paleontological material from similar sites across the territory. What made the Bluefish Caves collection different, what made Cinq-Mars stop and look considerably more carefully at what he was holding, was what some of those bones were carrying on their surfaces. Cut marks. Deep, thin incisions running in straight lines across the bone, with clean, V-shaped cross-sections visible under magnification. Not the ragged, irregular damage you see from carnivore teeth gnawing at a carcass. Not the scattered, unfocused scratching left behind by roots growing across buried bone over centuries. These marks were deliberate, controlled, positioned in exactly the locations a human butcher would target when stripping muscle away from bone. And the marks were not confined to just 1 or 2 specimens. They appeared across multiple bones from multiple species, recovered from multiple layers within the same deposits. Whatever had made these marks had been doing it repeatedly, across a genuine stretch of time inside these same 3 caves. Then came the find that would eventually define the entire controversy: a piece of mammoth bone that appeared to have been deliberately worked as a tool. Cinq-Mars and his colleague Richard Moreland identified what they described as a mammoth bone core, a larger piece from which a flake had been deliberately struck, and the corresponding flake itself, a sharp-edged fragment produced by that same controlled impact. The technique required to produce that specific result, striking a large mammal bone at the correct angle with enough force to detach a usable flake while maintaining a clean fracture, is not something that happens by accident. It requires a deliberate, multi-step process that no natural force or scavenging animal can replicate. Cinq-Mars ran radiocarbon dates on the oldest specimens. The numbers came back, and they were, by any standard of the time, extraordinary, roughly 24,000 years before present. Some dates reaching as far back as 28,000. Let those numbers actually settle, because their full weight is easy to miss if you move past them too quickly. In the late 1970s and throughout the 1980s, when Cinq-Mars was conducting this work, the accepted story of human arrival in the Americas centered entirely on the Clovis culture, dated to roughly 13,000 years ago. That was treated not as a working hypothesis, but as a hard, fixed boundary, the absolute earliest moment any human being was supposed to have existed anywhere on the entire continent. 24,000 years was not a modest challenge to that boundary. It was not a claim of arriving a few centuries earlier than expected, the kind of minor revision the field might have absorbed without too much disruption. It was a claim that humans had been present in the Americas nearly twice as long as the accepted timeline allowed. A full 10,000 years before the Clovis culture was supposed to represent the very first chapter of human life on this side of the planet. That kind of claim, backed by cut marks on extinct animal bone and radiocarbon dates from a remote Yukon cave, should have generated one of the most significant scientific debates in the entire field of American archaeology. It should have drawn researchers from across the continent to examine the evidence directly, test it rigorously, and either confirm or refute it through careful, sustained, professional scrutiny. That is not what happened. What happened instead is one of the ugliest chapters in the recent history of North American archaeology, and it would cost Jacques Cinq-Mars decades of his professional life. Cinq-Mars presented his Bluefish Caves evidence at professional conferences throughout the 1980s and into the 1990s. He laid out the cut-marked bones. He showed the mammoth bone core and flake. He presented the radiocarbon dates. He walked audiences through the excavation methodology step by step, the same way any serious researcher presents a decade of careful fieldwork to colleagues qualified to evaluate it. The response was not skepticism. Skepticism would have been reasonable. Skepticism would have meant engaging with the evidence directly, testing specific claims, proposing alternative explanations for specific marks on specific bones, and working through the data point by point until the strengths and weaknesses of the case were genuinely understood. What Cinq-Mars received instead was dismissal, and not the quiet, professional kind that gets recorded politely in footnotes and review papers. The open, personal, public kind. At one conference presentation, in his own words, they laughed at me. They found me cute. Sit with that specific detail for a moment, because it is not a second-hand rumor or an exaggerated retelling. Those are the words of the researcher himself, describing what happened to him directly, in front of his own professional peers, while presenting a decade of careful work conducted under genuinely difficult field conditions in one of the most remote archaeological settings in North America. Ruth Gotthard, a member of Cinq-Mars's own excavation team who went on to become a senior government archaeologist in the Yukon, stated the situation just as directly. In her assessment, the scientific community of the day simply failed to give the Bluefish Caves research a fair hearing. To understand exactly why the rejection was so total and so personal, you have to understand the wall Cinq-Mars was running into. It was the same wall that would later block the Page-Ladson tusk in Florida, the same wall that nearly buried Monte Verde in Chile, the same wall that dismissed the Meadowcroft rock shelter in Pennsylvania. Clovis first. For most of the 20th century, the accepted story of human arrival in the Americas centered on one single culture, the Clovis people, dated to roughly 13,000 years ago. That story had hardened, over decades of repetition, from a working hypothesis into something considerably closer to a fixed boundary, enforced not through ongoing testing but through institutional consensus that had long since stopped questioning its own foundations. Any site claiming a date older than Clovis was, by definition, wrong. Not possibly wrong, not worth investigating further to determine whether it might be wrong. Simply wrong, automatically, because the date itself fell outside the accepted boundary. The evidence was judged not on its own merits, but against a conclusion that had already been reached before anyone ever looked at it. Cinq-Mars was not presenting a minor adjustment to the timeline. He was presenting dates that were nearly twice as old as the accepted limit. And the field's response was not to examine those dates carefully and determine whether they could withstand genuine scrutiny. It was to treat the claim itself as so obviously absurd that the man presenting it could be openly laughed at without professional consequence. Think about what that environment actually does to a working scientist. Cinq-Mars was not an amateur enthusiast chasing a pet theory in his spare time. He was a senior curator at a national museum, backed by a decade of systematic excavation work, presenting physical evidence he had personally recovered and carefully documented across 10 full field seasons. And the professional community he belonged to responded by treating him as a joke. He stopped attending conferences. He stopped defending the site publicly. He stopped presenting new findings, stopped engaging with critics, stopped trying to convince a field that had already decided he was wrong before it ever seriously examined a single bone in his collection. The evidence went into museum storage. The bones sat in drawers. The cut marks did not fade. The radiocarbon dates did not change. And for roughly 20 years, nobody came back to look at any of it again. For roughly 2 decades, the Bluefish Caves collection sat in museum storage at the Canadian Museum of History in Gatineau, Quebec, carefully catalogued, carefully preserved, and almost entirely untouched by anyone outside the institution itself. Think about what those 20 years actually looked like, not for the bones sitting in drawers, but for the man who had pulled them out of the ground with his own hands. Jacques Cinq-Mars continued his career. He continued working at the museum. He continued conducting fieldwork in the Yukon during the summers, studying other sites, contributing to other projects. But the single most significant discovery of his professional life sat in storage, filed under a verdict the field had delivered without ever properly testing the evidence itself, using the tools and techniques a claim this significant genuinely deserved. And here is the part that makes those 20 years genuinely painful to look back on. While Cinq-Mars' evidence sat untouched in Gatineau, the very wall that had blocked him was slowly, painfully, being dismantled by other researchers at other sites, one agonizing fight at a time. Monte Verde, in southern Chile, dated to over 14,000 years ago, fought its way through the Clovis First barrier after years of sustained resistance, ultimately forcing the field's most prominent skeptics to travel to the site in person, examine the evidence directly, and publicly concede they had been wrong. The Meadowcroft rock shelter in Pennsylvania, with artifacts dated to at least 16,000 years ago, survived decades of methodological challenges and emerged with its dates intact. Page-Ladson in Florida was dismissed and ignored for 30 years before a second team redid the entire excavation from scratch and published 71 radiocarbon dates in perfect stratigraphic order, proving the original researchers had been right all along. One by one, across those same 2 decades, pre-Clovis sites fought their way through the exact same institutional resistance Cinq-Mars had encountered, and won. And through every single one of those victories, the single oldest claim of them all, the one with dates pushing past 20,000 years, the one backed by cut-marked mammoth bone and a worked bone tool recovered from the doorstep of the land bridge itself, sat in a drawer in Quebec, unexamined, unchallenged, completely unvindicated. While younger, less dramatic sites clawed their way to acceptance one at a time, the evidence that should have been leading the entire conversation gathered dust in a museum storage room because the man who found it had been laughed out of the room for presenting it. Cinq-Mars himself, by the accounts of people who knew him, had settled into something between resignation and quiet bitterness. He described the Clovis First establishment in blunt terms, calling their commitment to the old model something close to brainwashing. He was not wrong about the dynamic, even if the word itself carried more anger than precision. The field had genuinely failed to engage with his evidence on its own terms, and by the time pre-Clovis dates began gaining acceptance elsewhere, too many years had passed for the correction to feel like anything other than confirmation of exactly what he had already been saying all along. It would take a researcher from an entirely different generation, working at a completely different institution, someone who had never personally experienced the political environment that had buried the original findings, to finally walk into that storage room and reopen the case properly. Her name was Lauriane Bourgeon. She was a doctoral student, first at the Université de Montréal, later affiliated with the University of Kansas. And she did not approach the Bluefish Caves collection carrying any of the institutional baggage, personal history, or professional grudges that had surrounded this material for 2 decades. She approached it as a scientist examining physical evidence, applying modern analytical methods the field had not possessed when Cinq-Mars first presented his work in the 1980s. Methods designed specifically to distinguish with genuine, testable rigor between marks made by human tools and marks made by anything else. Bourgeon's study, published in the journal PLOS1 in 2017, was built from the ground up to survive exactly the kind of hostile scrutiny that had buried Cinq-Mars' original findings 3 decades earlier. She did not simply revisit a handful of the most promising specimens and declare them genuine. She went through the entire collection. Roughly 36,000 individual bone fragments, examined one at a time under high-powered microscopy, each mark on each bone classified using strict taphonomic criteria designed specifically to separate human-made damage from every possible natural alternative. Think about what that scale of analysis actually represents. 36,000 fragments, not a quick pass through the most obvious candidates. A systematic, exhaustive review of every single bone in the entire Bluefish Caves collection, conducted by a researcher with no personal stake in the outcome and no history with the political fight that had surrounded this material for decades. Her classification method was deliberately conservative, built to withstand challenge rather than to produce dramatic results. Carnivore tooth marks, the kind of damage left by wolves, bears, and other predators gnawing on bone, were identified and excluded systematically. Root etching, the shallow, branching marks left by plant roots growing across buried bone over centuries, was identified and excluded. Geological abrasion, the smoothing and scratching caused by sediment pressing against bone under its own weight across thousands of years, was identified and excluded. Only after every natural explanation had been methodically ruled out for each individual specimen did Bourgeon classify a mark as genuinely human-made. And even then, she applied the strictest available criteria. A human-made cut mark, under her analysis, had to be deep, thin, V-shaped in cross-section, and positioned on the bone in a location consistent with strategic butchery rather than random contact. The results came back at at least 15 bones out of 36,000 fragments examined, carrying definitive cut marks made by human hands, with every natural alternative systematically eliminated. The single oldest specimen in that confirmed set was a horse jawbone, dated to approximately 23,500 years before present. The marks on it were long, straight incisions running along the inner surface of the jaw, positioned in exactly the location a human butcher would cut when removing muscle tissue from the bone of a freshly killed animal. Not random scratches, not ambiguous damage that could be read multiple ways depending on the viewer's expectations. Deliberate, strategic cuts, made with a sharp tool by someone who knew precisely what they were doing and why. In 2021, a follow-up study revisited the single most controversial object in the entire collection, the mammoth bone core and flake that Cinq-Mars and Moreland had originally described decades earlier. This reanalysis applied the same rigorous taphonomic framework Bourgeon had established. The results confirmed what Cinq-Mars had argued from the very beginning. Both pieces showed fresh fracture patterns consistent with deliberate human work. Both carried fine striae attributable to cultural activity rather than natural processes. And critically, neither piece showed any carnivore tooth marks at all, eliminating the most commonly proposed alternative explanation in a single testable observation. Cinq-Mars had been right. The bones he pulled out of frozen Yukon sediment in the 1970s and 1980s, the same bones he had been laughed at for presenting, the same bones that had sat in museum storage for 2 decades, while the field slowly, painfully accepted pre-Clovis dates from other, younger, less dramatic sites, were exactly what he had always said they were. The oldest confirmed evidence of human activity anywhere in Canada, and among the oldest anywhere in the entire Western Hemisphere. But the significance of that confirmation extended far beyond simply vindicating one man's career. Because if humans really were present in eastern Beringia 23,000 years ago, living and hunting on the actual doorstep of the land bridge itself during the coldest, harshest phase of the entire Ice Age, that fact carries genuine, testable implications for exactly how and when the rest of the Americas were eventually populated. Long before Bourgeon ever opened the Bluefish Caves bone collection, geneticists studying modern Native American populations had already noticed something genuinely strange sitting inside the DNA itself. The genetic diversity patterns they found did not match a population that had simply walked across a land bridge and kept moving south without pause. They matched instead a population that had stopped, settled, lived in genuine isolation for thousands of years, genetically cut off from their Asian origins, before eventually dispersing southward into the Americas as the ice finally retreated. Researchers call this the Beringian standstill hypothesis. The idea, supported by converging lines of genetic evidence from multiple independent studies, is that the ancestors of all Native American peoples did not simply cross Beringia in one continuous migration. They lived there for thousands of years, an entire founding population isolated on the land bridge itself during the last glacial maximum, the coldest, harshest stretch of the entire Ice Age, when massive ice sheets to the south blocked any further movement into the continental interior. The genetics, said people, were there. What the hypothesis lacked for years was direct physical proof, actual, datable archaeological evidence of humans living in Beringia during that exact window. Bluefish Caves provides exactly that. The confirmed cut-marked bones span a range from roughly 24,000 to 16,000 years before present. That range covers almost the entire duration of the proposed standstill, from its beginning deep inside the last glacial maximum through to the period when the ice sheets finally began retreating and the corridors south eventually opened. The caves sit in eastern Beringia itself, on the actual land bridge, in the exact geographic region the hypothesis specifically predicts a founding human population would have been living. Think about what that alignment actually means, laid out plainly. One branch of science, genetics, predicted a population that should have existed in a specific place during a specific window of time. A completely separate branch of science, archaeology, independently confirmed that prediction with physical evidence from exactly that place dating to exactly that window. Two entirely different fields using entirely different methods arriving at the same conclusion from opposite directions. That kind of independent convergence is, in scientific terms, about as strong as evidence gets without an actual human burial to put a final, definitive stamp on the case. And here is where honesty requires naming exactly what has not yet been found. No human skeletal remains have ever been recovered from the Bluefish Caves. The stone tool assemblage is small and difficult to assign confidently to a specific cultural tradition. And the radiocarbon dates on individual specimens still carry ranges wide enough that specific data points remain genuinely debatable, even now, within the specialist community. This case does not rest on a single, unambiguous smoking gun, the way Lansau Meadows rests on its iron slag and bronze pins. It rests instead on a careful, cumulative, forensically rigorous analysis of cut marks, fracture patterns, and bone tool technology, tested and retested across multiple independent studies, all pointing in the same direction. Jacques Cinq-Mars lived long enough to see Bourgeon's 2017 paper published. After decades of silence, after walking away from a field that had publicly laughed at him for presenting evidence it was not ready to accept, the man who had crawled into 3 frozen hollows on a Yukon ridge and pulled out proof of human life at least 10,000 years older than anyone was supposed to believe, finally saw his work formally, publicly, unambiguously confirmed in a peer-reviewed journal by a researcher he had never met, using methods that did not exist when he first made the discovery. The bones did not change in those 30 years. The cut marks did not change. The radiocarbon dates did not change. The only thing that changed, the only thing that ever needed to change, was the willingness of the field itself to actually look at what had been sitting in a museum drawer the entire time. For 30 years, the oldest evidence of human life in Canada sat in a museum drawer because the man who found it was laughed out of the room for presenting it. The bones did not change. The cut marks did not change. The radiocarbon dates did not change. The only thing that changed was the field's willingness to actually look at what had been sitting there the entire time. Jacques Cinq-Mars crawled into 3 frozen hollows on a Yukon ridge and found proof that humans had lived in the Americas at least 10,000 years before the accepted timeline allowed. They called him cute. They stopped listening. And 30 years later, a researcher he had never met opened his boxes, examined his bones under methods that did not exist when he first made the discovery, and told the world he had been right all along. The caves kept the evidence. The field just was not ready for it. Subscribe for the next investigation.